Have you ever pondered over the power of the cosmos and how it can impact our little blue planet? In the remote wilderness of Siberia, a mystery unfolded over a century ago that still baffles experts to this day. The year was 1908, and the world experienced the largest impact event in recorded history. This event, known as the Tunguska event, unleashed an energy equivalent to approximately 15 million tons of TNT. Yet, in a twist that continues to puzzle, it left no tangible evidence of an impact. There was no crater to mark its landing, no fragments of a meteorite scattered about. The event was so powerful it flattened an estimated 80 million trees over an area of 2,000 square kilometers, and yet it left no trace of what caused it. This begs the question, what could create such a cataclysmic event without leaving a trace? Imagine waking up to a day that would etch itself in the annals of history, for reasons unknown and unexplained. On June 30th, 1908, the day dawned like any other in the remote Siberian region, home to the indigenous Evenki people. However, it wasn't long before the ordinary was eclipsed by the extraordinary. A bright flash, brighter than the sun, seared across the morning sky. Moments later, a heat wave, as intense as standing too close to a roaring bonfire, swept across the landscape. The tranquility of the Siberian wilderness was shattered. The shockwave that followed was so powerful that it knocked people off their feet, miles away from the epicenter. It flattened an estimated 2,000 square kilometers of dense forest, a verdant expanse suddenly reduced to a timber wasteland. The trees at the heart of the blast, oddly enough, remained standing, stripped bare and scorched, like skeletal reminders of a cataclysmic event. But the effects of that fateful day were not confined to the isolated Siberian wilderness. The ripples of the Tunguska event were felt across the globe. For days following the event, atmospheric changes were observed as far away as the United Kingdom and the United States. Night skies glowed brightly, so much so that people could read newspapers outdoors in the dead of night. Scientists speculated that this was due to the dust and aerosols thrown up into the Earth's upper atmosphere by the explosion, scattering sunlight. Yet, despite the global effects, the remoteness of the event meant that it was largely overlooked at the time. It would take almost 2 decades before the first scientific expedition would reach the site, and by then, much of the physical evidence had been weathered away by time and the harsh Siberian elements. A day of awe and fear, leaving behind a mystery that would puzzle scientists for over a century. In the quest for answers, numerous theories have been proposed, each more fascinating than the last. Our first contender in this cosmic mystery is the meteorite theory. Many scientists believe that a small asteroid, about 1/3 the size of a football field, exploded in the Earth's atmosphere. The strength of this theory lies in the fact that such an event is not only plausible, but has happened before. However, it falters when confronted with the conspicuous absence of a meteorite remnant. Despite extensive searches, no substantial fragments have ever been found. Next, we delve into the comet hypothesis. Unlike asteroids, comets are composed mainly of ice. This theory suggests that a comet could have exploded in the atmosphere, leaving no solid debris but causing widespread devastation. Its strength lies in the explanation it provides for the lack of physical evidence. However, it's weakened by the fact that comets are typically visible to the naked eye for days or even weeks before they reach Earth. No such sighting was reported in the case of the Tunguska event. Then there's the mini black hole theory, a rather exotic proposition. It postulates that a small black hole passed through the Earth, causing the explosion. This theory is undoubtedly intriguing, but it's also highly speculative. The biggest challenge it faces is that such a black hole would likely have caused more noticeable effects on the Earth. Lastly, we have the antimatter hypothesis. This theory suggests that a tiny chunk of antimatter collided with the Earth, causing the explosion. While this is a captivating idea, it's currently beyond our ability to prove or disprove, making it more of a scientific curiosity than a viable explanation. Each of these theories brings its own unique perspective to the table, offering a tantalizing glimpse into the possible answers. They've sparked countless debates and have driven years of research, yet despite their merits and drawbacks, none have managed to definitively solve this century-old puzzle. Yet the truth remains elusive, shrouded in the Siberian wilderness. Over a century later, the Tunguska event continues to intrigue and mystify. This spectacle of 1908, the largest impact event on Earth in recorded history, remains etched in our collective memory, a puzzle yet unsolved. We've delved into theories, from the fiery descent of an asteroid to the explosive end of a comet, each bringing its own set of questions, each adding another layer to this enduring mystery. The implications of the Tunguska event extend beyond the borders of Siberia. It throws light on our planet's vulnerability to cosmic objects, underlining the need for vigilant observation and preparedness. This event, dramatic though it was, serves as a reminder of the colossal power that the universe holds. As we continue to gaze at the stars, we are reminded of the power of the universe and the mysteries it holds. The story of Tunguska is a testament to our quest for understanding, a mystery that keeps our eyes turned skyward in awe and wonder.